Welcome back, everybody. We are going to get started with this session. Thank you so much for coming. I'm Ashley, I'm your MC. And during this session, we're going to be covering MongoDB search and vector search for use on enterprise servers. So at the end of the session, you'll see a QR code where you can leave feedback on a 3 to 4 question survey. So with that, I'd like to welcome our presenter, Rodrigo Leal.
Thank you so much. Hello everyone, my name is Rodrigo Leal. I'm part of the Industry Solutions team for MongoDB, based out of Mexico City. I have been with MongoDB for a little over 1.5 years now. And today we are going to be presenting something very exciting that was announced in today's keynote, which is the use of enterprise and vector search over enterprise server, or as it was known before, enterprise advanced. This is the topics we are covering today. We are going to be talking a little bit about the evolution of the MongoDB data platform and coming to where we are today. Then we're going to be getting right into it. Search over enterprise server. We are announcing today the public preview, which can be accessed as of today. And we are going to be showing how it works in terms of getting started, what are the requirements, what are the different steps we need to cover in order to enable search on enterprise server. And then we're going to be going through an exciting part, which is going to be a demo. In terms of the evolution of MongoDB, it has been an exciting few past years, but the most important part of all this content is that 1 year ago, a little bit over 1 year ago, we enabled vector search on Atlas. And since we enabled that, we have been getting questions: when are we going to develop, when are we going to be releasing search on enterprise server? And the answer is today. It didn't click. Okay. The important part is that enabling this kind of functionality on enterprise server takes the platform components, community, enterprise server, and Atlas to the same level of having all these different solutions consolidated into one platform. Now everything is together. We have, of course, the document model, we have time series, geospatials, etc., etc. Everything was on the different platforms, but now we are enabling this vector search, advanced search capabilities that we enable to develop new solutions, and they can be on-premise and they can be on Atlas as well. Today we are announcing the public preview of these capabilities. As of now, you can ask to be included on a public preview within your companies and go through all these specifications and go through this functionality, and we are looking forward to releasing this generally available maybe sometime next year. And where do we come from? I want to quote Jim Schwartz, which is our CTO, and I quote: "Our enterprise customers have told us that they want to harness the power of Gen AI on their own proprietary data. But the architectural complexity of bolting on separate search and vector databases has been a major barrier. By bringing the power of Atlas search capabilities to our self-managed customers, we are giving them the tools to begin innovating faster on their own terms. With this, you will have the capabilities of native MongoDB search with no external systems required. You will have all the additional capabilities like full text search and semantic search capabilities within, enhancing developer experience and allowing you the freedom to run everywhere." What were some of those key pain points that we are addressing today? First, the complexity of managing separate search engines. Before, you needed to have, if you didn't have Atlas, you needed to have different components. Also, maybe another pain point is the inability to use Atlas Search due to regulatory requirements, especially, for example, on financial services companies. They have regulations that don't allow for some of the information to be up there in the cloud. This addresses that. This, of course, led to limited search capabilities on local deployments, fragmented development. If you wanted to add some functionality of search, vector search, you need to have different components. Now you can have everything on the same platform. And of course, reducing the risk of investing in an architecture that might not align with the final product. Now you can have everything all together on the same platform. This announcement of this public preview that allows for enabling search on enterprise server will enable you to build the next generation of AI applications on your own infrastructure. Whether it is a local environment, it can be, of course, on any of the clouds, but on your own environments, you can use it. This will eliminate the complexity of the architecture having to be distributed across different products, across different solutions, and this can really accelerate development of new applications and reduce cost, while maintaining the same application code across all of the environments. These are some of the benefits that running search and vector search on self-managed clusters have. The first one, and most important, run your search workloads anywhere, locally, in the cloud, and then probably you need to move to Atlas in the future, you can do that. Avoid the synchronization tax. You can have everything all together. If you at some time need to move forward to Atlas, you can do so, or maybe you are running on Atlas now but need to copy or do an environment locally in your servers. You can bring all the information down from the cloud as well, and you will have a superior developer experience using a single API across all databases to perform the different search operations. So this is very important. Now you will have all the proven capabilities that we have in Atlas for the past year or so, and now you will have it on your local environment. So you could be asking this very important question: how can I get started? Of course, right now we are on a public preview, but we are going to be releasing documentation that will enable you to add these capabilities to a local environment. How to get started? The first step is to follow these prerequisites. You need to be running on MongoDB Enterprise Server Cluster version 8.0.1 or above. You need to run on a Kubernetes environment. So far, for this part of the public preview, we need to run on Kubernetes, and the counterpart of from MongoDB is running the MongoDB controllers Kubernetes, MCK operators, for short, installed in the Kubernetes cluster. These are the things that you need at first to be able to begin. Then, once you have all these prerequisites, you need to deploy the search nodes on Kubernetes. And we are going to be looking at some of the considerations we have. But at first, you need to create the custom resources in Kubernetes to be able to connect the search nodes and to your Kubernetes, to your MongoDB cluster. Then you can target MongoDB Enterprise Server instances deployed outside or inside Kubernetes. We support both modes. This is an example YAML file that shows how to create the search indexes, which is the next natural step. Once you set up your environment, you are going to be creating your indexes. This is an example for search index, and this is the example to how to create the vector search index. These are two examples that you can follow, and all of this, of course, is going to be shown in the documentations we are going to be releasing today, and also in the demo that I'm going to be showing after this. Once you have set up the environment, once you have created your indexes, you can query your data. You will use the $search command. This is a sample of how you can do that. This is very similar to what you are already using. The only thing that is going to be changing is the connection strings. Instead of using Atlas, you are going to be using that locally. We are going to be looking at that in a minute. And this is how you query your data using the $vector search tag. So these are two examples of how you can use search the way you are used to using it as of now in Atlas, but the main difference is you are going to be able to run that locally. And then you can monitor how everything is working. You can monitor the health, the status of the search node pods. You just run a simple command on your terminal, and you can be looking at how that works. And we are going to be showing an example in a few minutes. We are going to be running a demo so that you can see everything as it should work. But before we go into the demo, how does the architecture works? This is an example of the MongoDB server running inside of Kubernetes. So you can see on the bottom part of the screen, you have the different operators, the different search, the different Mongo server and ops manager, all together within a Kubernetes cluster. You can see the interactions with the custom resources we just created with MongoDB and MongoDB Search, and you have the customer interaction on top. This is an example of having everything together inside of Kubernetes. The alternative that I was mentioning you about is that you can run the server, the MongoDB server, outside of Kubernetes as well. But as I mentioned in the beginning, the search nodes, as of now, need to be running within Kubernetes, right? You will add all the connectivity through port forwarding or whatever method we need to use. You have the MongoDB server outside, you have Ops Manager, you have the cluster, and you will have the custom resources querying those different search nodes. And you have the user on top. Right? So let's go into the demo. This is a very exciting part because we are going to be showing an example of how we can use vector search with a live application. We are going to be using a retail example in which the user wants to be looking and searching for some products using full text search, vector search, and we are going to be showing the difference between running that in Atlas and running it on enterprise server. The difference is only changing the connection string. And because I'm not using my computer, because my presentation is somewhere else, we are going to be showing a video. So to reduce all the latency, and we have a lot of people here, and that's not my computer, so let's begin showing some video snippets of how this works. On the left side of the screen, we have the search input. In there, we are going to be using full text search, and then we are going to be using vector search. And I want you to pay attention to the middle of the screen. In the middle, we are going to be showing where the solution is running. So I'm going to be running this snippet. I will type in my query, I will use full text search first. I want to search for fruit. So on the left side, you can see the application. On the right side, you can see how everything is running. But the important part is the one in the middle at the bottom. I'm going to be zooming in, and you can see it's running on MongoDB Atlas. I wanted to show you first how it runs in Atlas, and then I'm going to be showing you how it works on Enterprise Advanced. Here is my environment variables for my server, for my deployment, in which I have the Mongo URI tag, and right now I'm connecting to Atlas. I'm going to comment on that, and then I'm going to be using the one string in the bottom, which connects to a local environment that has Enterprise Server. Basically, changing the connection from Atlas to my local environment. Once I do that, this is very easy. I just comment out the Atlas connection string and restart the service. Now I'm using my local cluster. In here you can see I'm connecting to Enterprise Server. Then I'm going to be restarting my application. It's easy as that. Once I have everything deployed, I just change the connection strings, restart or refresh my application, and once again I can run my full text search, and you will see in the middle of the screen that I'm running on Enterprise Server. See? Easy as that. Once I deploy, making the change to the connection string is very easy, and then functionality is going to be the same I'm used by using the proven technology of search by MongoDB. And you can see everything is running, everything is performing. I'm going to be having the same results as before. This is a copy of the solution, but instead of using search on Atlas, it's running locally. You see? Even things that I'm used at using, like fuzzy search, for example, I'm typing cookie with a U. I'm going to be getting results because it's using the same technology that we are using on Atlas. How do I set up the environment? This is a very important step to make everything that I just showed you work. To get started, we can use the MongoDB controllers for Kubernetes operator, that's the MCK, to deploy the search nodes. This is an example of how we can set up a script to do that. This is an example YAML file of the different steps needed to do the deployment. And this is the important part. This is where I'm setting up all the different connection strings. In this case, if I use the environment outside of Kubernetes. And this is not clicking, there it is. So this step enables search capabilities by creating the MongoDB search custom resources named MDB-RS and associated with the MongoDB instance. Right? This is a very small video of me running this script. This is having all the resources ready. And after I allow some time, the resources are ready so I can view how the running pods are being displayed, and this is the result. I here have all the different clusters, all the pods running. Also, I'm seeing the Kubernetes operator and the different search nodes deployed. Here is the documentation that is going to be needed. We are, of course, going to be showing and sharing these resources to you so that you can follow all the different steps, how to do the deployment, how to add the search nodes, how to begin making tests to query the different search, vector search or full text search, and how to monitor the deployment. All the documentation is going to be available as of today. And we are going to be showing some use cases now, some real-life examples of how we can use the technology in different industries. We are going to be showing a retail example, a financial services example, and a healthcare example of how we can enable different applications running search on vector search, run on enterprise server to allow for this flexibility and all this regulation compliance I was telling you about at the beginning. So let's go to the first example. This is an example of real-time personalization when a customer goes and purchases some products. Once they get the receipt, using vector search, we can search for similar products that the customer has acquired in order to make real-time recommendations of similar products as to enhance the ticket value and make more sales. The next example is on financial services. This is a simulator that allows me to detect fraud by examining some behaviors, some different following of rules. We can see which customer can be maybe liable for risk, for compliance, all of this using vector search. This is very important because in a matter of seconds, we can detect some opportunities that we may have in these regards. And by the way, I want to make the commercial that all of these demos that we are presenting right now are going to be available real time at our booth, and they can be accessed and watched there. And last but not least, we have another example for healthcare. Here we can identify by searching and using vector search critical patient information through natural queries, accelerating caring for decisions real time, of course being compliant with HIPAA standards that are related to healthcare, in order to safeguard healthcare data. In here, we can allow for these split-second decisions that can occur when using search to find products, to find patient information, to find data that we need in order to make decisions very, very quickly. So these three examples are live in case you want to see them down there. The important part is that now that you have search and vector search in enterprise server, you are going to be enabled to build full text and semantic search features directly on your self-managed MongoDB environments without any external engines, simplifying development. You are going to be having everything on the same application, everything on the same place, to being able to create these applications, accelerating innovation in your self-managed environments. With this, I want to ask this question. Are you ready to disrupt industries and unleash the power of software and data? You will have the capabilities of having all the information in your environment. Searching through it is very important in order to make applications that can be very intelligent, so to say, and paving the way for artificial intelligence in the future. Right? With this, I want to share this QR code in case you want to learn more about the industry solutions that we have available for you. We have our booth. We invite you to scan this QR code. My name is Rodrigo Leal. I want to thank you for paying attention for this session. And now I'm going to be inviting Mike Holland, the Director of Government Affairs from the Washington Post, to do a fireside chat and have a little bit of conversation about our joint venture together. Many, many things. Please, a round of applause for Mike, please. Many thanks, Mike. Welcome.
Sure, no problem.
So let's have this little discussion of how our companies are working together.
Sure.
We have prepared some questions for you, and
Okay.
I will start with the
Sure, no
question number
problem.
one.
Go ahead.
So, Washington Post has an underlying OS, so to say, which is named ArcXP. It started a few years back with MongoDB as a CMS, a content management platform. How has that journey evolved over the years, Mike?
Sure. So most people probably aren't aware of who ArcXP is. When Jeff Bezos bought the Washington Post, he spun the entire technology organization that ran the CMS and our DXP into a separate company called ArcXP. That company over the last 7 years or so has begun to power not only the Washington Post, but about 2,000 of the largest news and media sites across the world. So Boston Globe, Atlanta Journal-Constitution in the US, a number of broadcasters overseas, La Parisienne, New Zealand Media and Entertainment, Chosun in Korea. So a lot of global content sites. And we run not only their content management system, but we have a DXP platform that runs their websites as a service. As Rodrigo said, we've had a relationship with Mongo for a long time. Our platform in general, and I'll simplify a little bit, we have a core content management system that stores all of our information, whether it's text or video or pictures. And then we push all of that content into a denormalized format to speed up delivery. All that information is stored in Mongo and then delivered out through the Akamai CDN out to all of our sites. We run that entire platform based on a pretty modern microservices architecture. And that platform is one that we've been kind of evolving over the last 7 or 8 years. Things have started to change though, so, right.
Many things,
Yeah,
Mike.
yeah.
And in terms of artificial intelligence,
Right.
is there like a way you are following through enabling some of the things that we just talked about, search, vector search? How are you using those today, or if there are plans of continue doing that?
Sure. So we were pretty lucky. About 3 years ago, Arc had a labs group that got involved in ChatGPT and a lot of the LLMs pretty early. Obviously, categorizing news content is a big business value. Both taking content and categorizing it for tagging for sections of a newspaper, or tagging it for advertising use, monetization, other use cases is a very, very large operation. In the past, that's been done through NLP, categorization, those kinds of technologies. About 3 years ago, our internal team started to investigate ChatGPT and what we could automate. Obviously in news, everybody is terrified of AI-generated content. We're powered by news organizations. They were not interested in AI writing stories. What we were using it for, though, was to assist authors. So within the author environment of our CMS, we started implementing a number of different LLM technologies: auto summarization, tag recommendations, translation, text-to-speech. But we were building it all from scratch, and that was getting to be painful. At the tail end of that, about a year ago, we started experimenting with vectors on our own, and it dovetailed with what Mongo started providing. As we've been rolling out our POCs ready to go to scale, it's really the same story we've had with Mongo in AI that we had with them originally on scaling our overall network, which is that at the point where our kind of POCs and MVPs for both AI technology and for vectors were ready to go to prime time, Mongo's now been able to help us with those very practical challenges. As you mentioned in your conversation, page 1 of the story is quite straightforward. You generate embeddings, you search the embeddings, everything's great. Well, page 2 of the story is really hard. How do you do compliance? How do you do local development? How do you do a pipeline of content? And as an aside, like, a lot of people think of news as fairly straightforward, but the challenge with news right now is that the pace of updates of content and the pace of spikes on the front end create a really dynamic caching environment. So we need a system that's very tolerant to the news cycles, and it needs to be tolerant both from the writing of content and the pulling of content, and then follow all the rules correctly. So Mongo's been able to help us scale with that, and as we've been moving into looking at vector searching, similarity, all those kinds of capabilities, including recommendations, which I could talk about for a little while, it's really been important for us in our forward-looking roadmap.
Awesome, Mike. Many things. And regarding that and following up on that, outside of the technology, how has the MongoDB environment, the sales organization, professional services help you along the way?
Yeah.
How has it been?
Yeah, I mean, give a shout out to Peter, who's our account manager, who's been helping us for a while now. One of our challenges has been, there are areas where we wanted to do proofs of concept. So as I said, we had our own labs team that was doing kind of generic AI platform that we provide to our customers. We've experimented with all kinds of different solutions. One of the areas where we didn't have a lot of experience was search and those kinds of pipelines for reader-facing search. We identified it pretty early. Peter had his ear close to the ground in working with our labs team and our AI group, and realized that that was an issue that we didn't have the expertise to deal with. He was able to rally different parts of the Mongo ecosystem and hooked us up with one of their partners called Prerequisites, who immediately worked on a collaborative project with them, the Mongo solution design team, our solution design team, and we've been building out together a proof of concept for a new kind of reader-facing search capability that would allow us to do kind of a next-generation vector search for users. And we wouldn't have been able to do that on our own. We would have been solution designing internally for a long time. Not only do we get the expertise of Pure Insights, but Mongo was talking to us immediately about how do you deploy this, what would it look like in your environment, and talking with our teams in real time. And this happened in the matter of weeks, right? So this wasn't like a quarter-long process. We started right off the jump. So
wonderful, wonderful. Many thanks, Mike. And you mentioned at the beginning that ArcXP runs media globally. What's it been like scaling MongoDB across these so many regions?
Yeah, I mean, this is not as much about the part that you covered, but right now Arc is running in multiple regions with multiple fault tolerances. We're integrating with AWS in all those regions, all over private link. So we have a very complicated GDPR infrastructure that we have to run all the time. And our content pipelines, our delivery pipelines, all of those are, as you might imagine, heavily, they're heavily analyzed by the home governments. They're also heavily attacked. One of the side effects of the AI revolution has been bot scraping of news organizations has exploded. It's all over the tech press, but that part of our ability to scale our delivery infrastructure has become a major part of our competitive advantage. And a lot of that is because we've been able to build these layers, both through our CDN and through our Mongo retrieval layer, so that we're not getting hit on our core infrastructure. So these ability to scale, to manage it, were important. And I would note that, Arc's background was running high-scaled, multi-clustered environments in AWS, and we're still very happy with how Mongo hosts our systems for us, even though as a business, we host infrastructure as a living. So it's been a big, it's been a great partnership on that front.
Many, many things. And looking forward, Mike, to the future, where do you see the biggest opportunities between MongoDB, AI, and ArcXP?
Yeah, so I was a little upset that none of your demos were news and media, but it's all right. One of the biggest challenges in news right now, as I think many people are aware, the traditional news model is under assault, both at a technical level and kind of industry level. One of the areas where we're working a lot, especially with AI capabilities, is that, recommendations 1.0, everyone's seen it ever since, My Yahoo, where you could build a My News page that looks at what you liked, uses collaborative filtering or NLP analysis, and recommends other stories you might like. We've been doing that for years. Most people did it with client-side technologies because it didn't scale. The next generation of that, about 5-6 years ago, was to do it all server-side, edge stitching, all those kinds of things. But where this is really going is the world called hyper-personalization. And hyper-personalization means we're not going to just deliver you the stories that you want. We're going to actually deliver a different story to you based on your interests. Did you read this story yesterday? We could actually have the update tailor itself for the paragraphs of information you hadn't read already. We could alter the story so that if we know you're driving home in your car, we'll turn the story that's remaining into an audio file and let you listen to it on your drive home. And when you switch, you can go back to reading it again. If you're like me and have younger kids who can't watch TV without closed captioning on, we can do that too. Present an experience that shows video with a little bouncing ball on the closed captions. Those kinds of hyper-personalized experiences require a lot of rethinking of what does it mean to do content search? And honestly, in the news and media world, what does it mean to be content? Is it a story? Or is it a collection of paragraphs? Or is it taking a story and turning it into a timeline? Or taking a story and turning it into a choose-your-own-adventure book to engage people with the subject? One weird aspect of this has been the Washington Post launched a tool called Ask the Post, where you could read about climate information, and then you could use ChatGPT to talk to the stories that the Post has written about it, in addition to the research that they did to write the stories. This isn't just an LLM scraping the content. They actually had more content that was vetted and curated that's now available through a ChatGPT interface. This kind of change in what it means to make content and retrieve it are the kinds of things that we only see line of sight on with technologies like what Mongo's doing.
Mike, I really want to thank you for this opportunity of chatting together. I really appreciate it. And maybe many thanks to the audience as well for being here today. And looking forward to our next collaboration.
Great. Thank you very much, everybody. Okay. Thanks. Take care.
Many thanks for attending this session. I wanted to really appreciate your participation on this. If you have any questions or any comments regarding this session or the Fireside chat, please feel free to do so. We are going to be available at the MongoDB main booth on the back to the right. And once again, many thanks for attending this session.